the second question says we should add this water to C and stir. The second question of C and stir. So we have recorded the test already. We'll now go to the experiment. The composition of C is this one. Then we're adding water to it. Are you seeing it? So you have stirrer, you can put a glass water and stir it. You don't have stirrer, you use your thumb and close it. It's not harmful. This is a carbohydrate. And then what? Shake it. You understand? The same effect of on stirring it. Shake it vigorously. It's meant to dissolve. Are you seeing it now? Yeah, are it dissolved or not? Because you're seeing nothing inside it. Are you seeing it now? I will know that in chemistry, most organic compounds are not polar. But carbohydrates are polar. Likewise, alcohols are also polar due to hydrogen bonding. So now write here, our observation, it says C is soluble in, okay, C dissolves, by the language, dissolved, in past tense, completely in water to give a colorless solution. C dissolved completely in water, give a colorless solution. This is 1A, this is 1AI, then 1AII. So what should be our inference? When C dissolved completely in water, what do we say? C is what? No? It's not like C is what? Polar. Are you following? C is polar. So whenever you come by the word, say the compound is polar. You don't have to say that C contains hydroxy group. No. C is polar. That is okay. That takes care of this problem. Then the third one says the solution from what? What solution is 1AI? This one. Test with what? Litmus papers. Okay, we'll go to that. Now I say, is it 1B or what number there? 1B what? I. That is single I. So I'll say, instead of saying solution from BII, you don't have to start using number. You can just write C what? What does it mean? Solution of C. Remember it's different for this one though.
Yes.
This one we're using ordinary C. So whatever you write here will score you here. If you report wrongly, you're going to get 0 this side. So plus litmus papers. There are 2 litmus papers, you know that. So we're going to take the litmus papers. We have the blue one and the red one. This one is blue one. Then you just insert it, let it touch the liquid a little. Only few seconds. The change will, there'll be a change. There's going to be a change. Is there any change on it?
Yes.
Wonderful. Are you sure?
Yes.
So let me see the red one. No change. Let me repeat this one again. Are you sure there's a change on this? Let's view very well. No change. There's no change. Still remaining the same.
There's a change.
Faint. Not all that. There's a change.
Change.
So we can say C aqueous turned blue litmus paper to faint red and had no effect on which one?
Red.
On red litmus paper. Then you now write here C aqueous is what? Is acidic, not an acid. Is what? Acidic. Don't say it's an acid. What the next question following it? Is it 2A?
No.
Is it 1B or 2? 1BII. What the question there? From what? So that AI is see this one now. That is C aqueous. Now the C aqueous, that is the solution of C now. Plus what? Failing what? Solution. Failing solutions A and B. Are you following it now? So this is the C solution now we have. That's the C aqueous. That's the one we obtained from 1A II, which we also use in the litmus test. Then all you have to do is get a filled under a clean test tube. Estimate 2C. Just collect a small amount from here. But this is too big for our experiment. So you just collect a little amount to represent here 2CN cube. Are you following it now? So it may not be as much as this. Just take a small amount of this and then add failing solution. So we're going to have failing solution. We don't have it here. Hold it. So we get a failing solution. This is the failing solution A. Why that C aqueous? I'm going to add a small amount on it, into it. Are you seeing it? What color are you observing? This green? Bluish green, okay. The first solution B. Are you seeing it? Blue. Then we write here C aqueous. Turns what? Turn what? Blue in color. Are you following it? That's the color you're observing. You don't give any inference yet. No inference on this. We are told to heat. Yes. And I'll say plus heat on a different line. Plus heat. So you're going to heat this. You get a clean boiling tube. So I told you before that if you want to heat, you don't heat with the test tube. Use the boiling tube. Transfer this into the boiling tube. Are you following it now? The boiling tube and then heat this. So heat until you have an observable what? A difference here until something happens.
Tell me something. I'm seeing black. I'm seeing black.
No, is it a wind or whatever?
No, it's drying up.
Is it drying up?
Candle and do this thing. They say Bunsen burner fixes Bunsen gas. It's drying up. It's drying up.
Come and switch off. Can you watch it from the inside? Watch from the inside of the tube. What color are you seeing?
Black.
It's not black.
Brown.
It's 107.
This is called brick red. Brick red. Are you seeing the inside? Brick red is one, or the, somehow can call it reddish brown. Braised with it. We're gonna have here brick red. Braised with it. Are you following it now? Then you now write your inference now be reducing sugar. Reducing sugar in bracket, you can write what in bracket? Glucose. Confirmed. You know that we are using glucose because glucose is not the only reducing sugar we have. Fructose can still do that. Equation that is 2A using the metallic oxide. So we are still on test, observation, and what?
Inference.
Inference. Read number 2A for me, please. That is D now. D plus heat. What is heat D? And they say D is an inorganic substance or metallic oxide. So go to heat D. I will use this test tube. I mean this boiling tube. This is our D. Also white in color. So I can't heat with the test tube. I'll transfer it into the boiling tube. And then heat D in the boiling tube. So, where is the rag? That I was using before. So, is there any color change on that?
Yes.
Funny what?
Yellow.
Yellow. Which metallic oxide can be heated? It gives all yellow color when it's heated. Zinc oxide. I guess we're going to find out. Okay, it's only is yellow somehow. Okay, that is not pity. We were hitting long for a long time, it's going to turn yellow completely. But we know that it's going to be yellow. Did they say we should allow it to cool?
Yes.
So you have to heat it and allow it to cool. So I still keep it here to cool and then observe the color after cooling. So I'll write here D turn yellow on heating. What was the previous color? White. So turn yellow on heating. The yellow color stay there. Look at it very well. Yellow color is coming back to what? Forget this yellow is not part of it too.
It's
Coming back to what? White. So we now say on heating and revert to white color. To white on heating. On cooling, sorry. So that is it. So our inference now say zinc 2 ion present. Zinc 2 ion from what? Zinc oxide present. Because that is the oxide. So having done that, what the next thing? We have the next. What the next test we have to do? Add what?
5 cm.
now say D plus 5 cm cube of dilute N2SO4 plus heat. That boy means heat. So we look for N2SO4 and add some amount of it, that is C, to D. Are you following? That's enough. Okay. And we're just estimating the volume. So if you have a measure in that, you can measure. But this is not volumetric, this is qualitative. So you can just take a reasonable quantity. Are you following? You don't have to fill the whole test tube, the whole boiling tube. And so they say we should boil. Can you light? Okay. Stay away from the heat. Okay, that's all right. Thank you. Why are we boiling? To hasten the rate of reaction. And perhaps to see whether the oxide will dissolve inside the acid. As we are boiling something and the liquid wants to what? Come out from the what? Test tube. It's boiling at a high rate. What do? You continue boiling? You remove it. Are you following? Yeah. And when you're boiling, you make sure that this test tube is not what? You don't channel it to somebody's face. Do you understand it now? Or to your own face. Keep it away from your own face. Don't know where it is. Look at where my face is. Before I make yourself a blind person. Okay. We'll see how some crystals there, man. I think if I add more acid, it will dissolve. Or if I made that acid a little bit concentrated, it will dissolve. So you can switch off the water. Dissolved to give a colorless solution. Because this is have zinc 2 ion present because zinc salts has the what? Colorless in what? In the aqueous solution. What the next test, please? You need to be what? 2C. 2CNC or what? From 2B. That is what's the solution called? The aqueous. What are we adding? Hydroxide in drops. And they say in excess. You have to do it step by step. You do the one in drops for excess. So you take a test tube, or shake to make sure I have a uniform mixture. Collect small amount of this, that represents my 2CNG. They are going to add one sodium hydroxide. In drops, we just add a little drop. Hey, I made a mistake. But anyway, I'm still having the effect. I added another one, an error, but it's still there. You have to observe. You can see at the rim, you are having some what? Light white, not so? Yes. That's what called white what? Gelatinous. That is, you can see the gel nature of the white. Mistaking they are poured more than enough, but if you add a little drop, it becomes very obvious. So this is what's called white gelatinous precipitate. Are you following it? Then I'm going to add the hydrolyte in excess again. The excess means add more. Maybe you ought to half for the test tube or more than half. Then you look at it. Are you seeing anything inside again? No. So that white substance looks like a gel had disappeared, had dissolved. So our observation and inference will now be in drops, right? White gelatinous precipitate. What are the cations that normally give us white gelatinous precipitate with sodium hydroxide? Zinc is there, not calcium. Calcium cannot give gelatinous. Zinc and or what? Aluminium. Lead is off, I hope you know that. Now as a present. Please don't put and. Comma means all, because it's one salt. Then plus sodium hydroxide aqueous in excess. There are plenty of it. Now write white gelatinous precipitate dissolved to be a colorless solution. So now right here, zinc 2, is this zinc 2? Okay, zinc also what? Aluminum, the two other will be certain. Present. You don't say confirm because you are suspecting 2 ions. Okay? Then having done that, we'll go to the last test. What that one saying? Under 2 cm cube, that is D aqueous. Add what? Ammonia in drops. These are different tests and then in excess. Now, since I'm done with this test, this is the one I added to my brother. I'm done with it. I don't need it again. Are you following it now? What I'll do is what? I'll pour it what? Away. If I want to make use of the test tube again, or I look for a fresh test tube. So once you are done with any test and there's no connection between this test and the one coming, that means you are done with the report. You can what? Discharge it. And then use what? Distilled water and rinse the what? Test tube. So you rinse it for another test. So this is the same solution. The same D. You collect also 2 cm cube. This time around, you are testing with what? Ammonia. So where is our ammonia here? There should be ammonia. NH3. We've got ammonia. Let's put this one down. You see ammonia in drops. I have to be careful this time around. Just a drop. If I have a dropping, I will provide a dropping pipette for you. Okay, this is just a drop that entered. Look at the rim. Close the rim. You see something that is whitish, like a gel. Are you seeing it? That's something that those are cloudy in appearance. There is something inside it. That's gelatinous also. Then in excess, ammonia. You see, it's clearing and becoming somehow colorless. Are you following it now? So you dissolve as long as you add more ammonia or you concentrate ammonia, you're going to dissolve and clear totally. So we now have our report will now be white gelatinous precipitate that is formed when you are added in drops. Of course, what do you have here? Zinc 2 or what? Aluminium present. Because if you don't put gelatinous, you can now include what? Lead. Then, but be very short, since you are sure of what you are seeing. So go straight to the point. Then plus ammonia aqueous in essence. So now I'll say white gelatinous. See, no longer there. White gelatinous precipitate dissolved to give a colorless solution. So the ion that is now we have standing there is only what? Zinc.
Zinc.
When I say zinc 2 ion compound. You can now stress zinc. So we now see that from our experiment that C is reducing sugar, that is glucose, and D is a zinc oxide, metallic oxide, zinc oxide. We are tested on. So you go through this time for you to practice your own, and then repeat the experiment, and then get used to it. Thank you.